as you look at section 1.3, notice is a page full of 12 different graphs, right? These are graphs that you need to be familiar with. These are graphs that if I say y equals x squared, I need instantly, or close to instantly, a graph to pop into your head. You're like, okay, yeah, I know what y equals x squared is. But not just on that one, that's an easier one that we've been working with since Algebra 1, but on all these. Okay, that you have a graph that you can visualize. So what we're going to do is we're going to talk through each of these. We're going to sketch a graph. We're going to talk about their domain and range, the qualities of these graphs. And then what your homework is your homework is answering questions about these graphs. So if you look at the next page is the type of homework you'll have where it's looking for graphs that have certain qualities. So today, we'll just work to talk about the graphs. I have no problem if you want to graph them on your calculator. I'll probably graph some, if not all of them, on the calculator as we go. But some of these I would like to think that you know. Some of them not so much. So this is a page you're going to need to memorize, guys. So first one, we call it the identity function. Notice the equation is there, and the equation for the identity function is y equals x. What does the line y equals x look like? Okay, positive slope going through the origin, up 1 over 1, right? So it's what you will sometimes hear referred to as that perfect diagonal line. I'm not going to graph that one on the calculator, sorry. Okay, so that's y equals x. So you need to be able to pair those three things together. Identity function is y equals x, and it's that graph of that diagonal line. Okay, now let's talk domain and range before we go on. We're going to answer these in interval notation. That's how we're going to write them down. Domain. How far left does my graph go? How far right does my graph go? Negative infinity, positive infinity, because a line goes infinitely, right? So if you want to put it in words, my domain is all reals, or negative infinity to positive infinity. Range. How high and low does my graph go? Yeah, my graph goes infinitely low and infinitely high. So my range, my y values are also all reals. Negative infinity to positive infinity. Are we okay with the first one? That should be the easy one to memorize, right? Okay, the next one. They call it the squaring function. The equation is y equals x squared. What do you know about that? Okay, we also call it a parabola, yes. And what does y equals x squared look like then, if it's a parabola? It's the U shape, and what does the basic one go through? 0, 0, right? Y equals x squared goes through 0, 0, 1, 1, 2, 4. Again, I don't feel like I need to graph this on the calculator. I feel like you've got it. Graph it if you want. Domain. How far left does my parabola go? How far right does it go? All reals? Because as what's happening, as my graph is going up, it's getting wider. And as it's getting wider, technically, it's all reals. Negative infinity to positive infinity. Range. How low does my graph go? How high does it go?
0.
Okay. So my y values on this graph is everything 0 and above. Because what's the first y value we have? It is 0. My graph goes through 0, 0. So this is 0 with a bracket up to infinity. Or it's all value y greater than or equal to 0. Okay, those first two are old news, right? I would like to think we can come up with a picture of the next one, called the cubing function. Y equals x cubed. as we draw them in the air. Is that what we're doing up here? Y equals x cubed. What's y equal x cubed? Can you visualize it? Yes? No? What? Starts low and kind of squiggles through the middle there. When I draw it, it's increasing, jogs through the origin, looks something like that. You know what that point at 0, 0 is called? I don't think we've really talked about it. I mentioned it in one of my classes yesterday just briefly, but okay. This point right here where my graph turns, it turns from facing down to facing up. Its concavity changes. But this is at 0, 0 is called a point of inflection. Because what's happening is my graph changes the way it's shaped. It's kind of shaped and curved down, and then it's shaped and curved up. So at 0, 0, there's that point of inflection. So cubing function, y equals x cubed, that snaky curve. Domain. How far left, how far right is my graph going? All reals? Negative infinity to positive infinity. Range. How low does my graph go? How high does my graph go? Negative infinity to positive infinity. All reals? Are you guys seeing these? I don't feel like I've thrown anything too tricky at you yet. Okay, so that's row 1. Identity, squaring, cubing. Start memorizing. Okay? I'll be honest, I kind of memorize these based on where they're at in my page. Okay, that's what I kind of do. So, that's top row. Okay, you ready for row 2? The reciprocal function. You know what this looks like? I don't expect you to on this one. Okay, so, if you don't know what it looks like, wouldn't hurt to look at it on the calculator. It's 1 divided by x is what that says. Okay. My calculator shows it as such. You have 2 curves in opposite quadrants, diagonal quadrants, facing away from each other. If we zoom in, and that's zoomed in a little bit too far. There's a zoomed in picture of what's happening there. I think I'm going to go back to the other one. I like that one better. Okay. But the idea here is this graph is running out and alongside both axes. Okay. This graph is also called a hyperbola. That is something we'll talk about in, I don't know, is it chapter 8, I feel like? But it's a hyperbola. If you look at the graph, do not let the calculator fool you. This sometimes happens more with the verticals. What does it look like is happening about right here? It kind of looks like the graph is ending, but it's not. Okay? It is going infinitely up and infinitely down. So this is a hyperbola. Reciprocal function, 1 over x. Domain. How low and high? No, domain. How far left, how far right is my graph going? What's happening as you go off to the left? It's going infinitely to the left, yes. And it's also going infinitely to the right. Is it fully connected all the way along? Does everything exist? No, because what's happening here? It doesn't stop from -1 to 1. It technically, where is this vertical asymptote, guys? X equals 0, right? If you set the denominator equals 0, there's a vertical asymptote at 0. On the left, my graph is going all the way up to 0, just not touching it. On the right, my graph is going all the way up to 0. So, yes, I'm almost all reals. It's all reals except 0. Now, how do I write that interval notation? Where do we start on the left at? Negative infinity. I'm drawing. How far do I go before I have to stop? We have to go to, what x value is this? 0. So we're taking a break at 0. My graph does not touch 0, so I'm using a parenthesis. Then we have a second part, so I'm going to use a U for union. And then where are we picking back up? We're still 0, okay? So this is how you indicate that there's an asymptote. 0 to positive infinity. Range. How low do we go? All the way down to negative infinity. What's happening is we're moving up the graph. You have a break at 0 again, don't you? So your range, even though it's y values this time, is the same as the domain, where it's negative infinity to 0 with a parenthesis, union, and then 0 to infinity. The difference is with the range, it's down to up. Okay, that's probably a good place to stop. I would like to think maybe you know what the square root function is because we've worked with it this year. But we'll pick up tomorrow. Tomorrow we'll finish going through the graphs. We'll do some of the example questions, and I'll assign the homework. You're welcome to go ahead and start looking at it, but until we see all these graphs, it's going to be a little challenging.